All right, so we're continuing here in chapter 9. As a quick review, we're looking at joints, right? 4 big types of joints. The osseous joints, the ones that are joined with bone, right? Bone actually grows between them, and you get very little movement. You have the fibrous joints, where it's connective tissue holding them together, and there were 3 different types of those joints. Those are a little bit more motion, not much, but a little more. Your cartilaginous joints, where you start to get even more motion, like between the ribs and the sternum, those joints there. And then our last piece was the synovial joints, where we actually get much more range of motion with those synovial joints. As we talk about these 6 types of synovial joints, one of the key points that you'll see us keep coming back to are the axes of motion. Because it's one of the ways of you defining what type of joint it is based upon how it moves. Okay? So, a moving bone has a relatively stationary axis of motion that passes through the bone in a direction perpendicular to the plane of motion. A multi-axial joint is a joint that has more than 2 or more than 1 degree of freedom. In other words, you can move it in different ways. Let's look at the shoulder as an example. Okay? Are you comfortable that I can move my shoulder like this? Right? I can move it like this. Right? Or I can rotate. Okay? So the shoulder is a multi-axial joint. Okay? If I am biaxial, how many axes do I have? 2. If I am monoaxial, how many do I have? 1. Does that make sense?
So if they say like you can move it in the frontal plane.
Sure, you can. What does that mean? So the frontal plane runs in what direction? It slices you into front and back, right? So a frontal plane would be this plane. I can't get off of that plane. This would be off of that plane, right? It's trapped in, so it'd be abduction and adduction.
Oh, okay. And so like if you're moving like
this way would be in the sagittal plane, okay, right? This way, that's rotation.
Okay, that makes sense.
Yep. There's only the 3 planes that we have in our body. Remember these, right? The frontal or the coronal, the sagittal, and the transverse. Okay, these are the planes we're talking about. These are the axes of motion. Are we good? And then there's a nice little picture that's there in your textbook that shows here are the different planes of motion, right? Abduction means this way, like you're doing a snow angel or a jumping jack. Flexion is this way, okay? And rotation is this way. Sir? Here we go. Yes, they have it down here, but I'm showing you up here. It's the same thing. It's just the bone itself is actually rotating on an axis that goes through the long axis of the bone, of your humerus. So here's my humerus, and my humerus is twisting. Okay? So 6 types, 6 classes of synovial joints. There's a lovely picture that's there, this exact one, on page 284. I encourage you to check that out as we're going through, because you can see the good joints, see, the actual pieces that are there. Boy, excuse me. Got to get my own study guide out here so that I'm having the same thing here as what you have. All right, number 1 of our 6 types. And if you want the names of them all at one time, ball and socket, condylar, saddle, plane, hinge, and pivot. Makes you think of Friends, right? Pivot, pivot. Good. So, number 1, the ball and socket joint. Every time we move, I have to say that. Every time we're lifting a couch or doing something. Anyway, it makes me chuckle. It makes me laugh even more that you all know that. That actually makes me chuckle. Okay, ball and socket. These are where I have a nice, smooth, hemispherical is the word that they use here. In other words, round ball that's fitting into a nice deep socket. Okay? A cup-like socket. And the obvious example of that is your hip and your shoulder, right? The femur and the acetabulum coming together, right? And that allows motion in all three planes, okay? It allows flexion and extension, that's one plane. It allows abduction and adduction, and it allows rotation. Does that make sense? Okay, multi-axial for these guys. The second is the condylar, or also ellipsoid is another word. I don't think I gave you ellipsoid, I just said condylar. Okay, so this is where we have a convex surface that's an oval convex surface of one bone fits into a complementary shaped concave depression in the other. This is a biaxial joint, allows more than one motion, allows two different axes of motion. And examples they give you are the radiocarpal bones. So again, remember, joints are names for the bones that make them up. So radio means what? Radius. Carpal is carpals, right? So this is in your wrist, right? The joint between the radius, which again, the radius is lateral, ulna is medial in anatomic position, right? So between the end of the radius and your carpal bones. That joint is condylar. Or the metacarpal phalangeal joint. So metacarpo is what? The metacarpals, right? These guys here in your palm of your hand. And the phalangeal is phalanges. So between your metacarpals and your proximal phalanges. Does that make sense? Here's your ball and socket joints. These are x-rays showing your shoulder and your hip. Here is the condyloid or the ellipsoidal joints, which are these blue ones highlighted there. The metacarpophalangeal joint. Yeah. Cool. And they said your arm's going to fall off or what? I'm sorry. There's good prostheses out there now. So that's all right. All right, number three. Number three, we have a saddle joint. A saddle joint. This is where both bones have an articular surface that is shaped like a saddle, where one surface of it is kind of convex, the other is kind of concave. And these, again, are biaxial joints. 2 degrees of freedom, 2 axes of motion. And our example is the trapeziometacarpal bone. So the trapezius is actually one of the specific names of the carpal bones. Okay? So between your wrist and your thumb in particular, we're talking about this joint right here. Okay? That allows your thumb to oppose, to make this motion, which is what sets us apart from an awful lot of other mammals, that we can do this. Okay, so we can actually use our hand to grip and hold things. Okay? The other place that we see that is the sternoclavicular joint. Sterno is what? Sternum. Clavicular is clavicle. So the joint between your sternum and your clavicle. So this right here. Does that make sense? We show you those saddle joints that are there. Did we already talk about the plane? Oh, it's there too. My apologies. Here's the plane joints, our joint number 4. The plane joints. This is where we have 2 flat surfaces that are together. And the bones just kind of slide over each other. There isn't any significant rounding to them. They're pretty flat and they just kind of rub together. Those are usually biaxial bones, though they can be monoaxial. Mostly biaxial. Some examples. Between the carpal bones of the wrist. Because remember, you've got 8 different bones that are here in your wrist. They have little motions you can make between them. They're basically just kind of flat in together, and they will allow some motion in 2 planes. Between the tarsal bones of your ankle, so calcaneus and talus and the cuneiforms and the cuboids, these guys can move a little bit between them. Also between the articular processes of the vertebrae. Are you comfortable that there are tons of little joints all along your spine where each of these little processes come together and they're basically just flat and they will move back and forth. Small amounts, but they will allow for movement. Like basically where between all of these little places, I can't really lift these up because they're But imagine if I were to lift this up. There's lots of different contacts between these guys. And those are all these plane joints. And again, here's the examples that they're showing you here of these different spots. So we're still at biaxial, right? Still not multi-axial. Only multi-axial is the ball and socket, right? Where it has more than two, or all three planes. These guys are usually two. Our last two we have are the hinge joints and the pivot joints. So the hinge is where we have one bone with a convex surface fitting into a concave depression of another one. You said, well wait, Mr. Hess, that's what you said condylar was. Yes, they're very similar, except that hinge are only monoaxial. They don't allow for more motion other than just in one plane, if I may. Thank you. Your classic example is your knee and your elbow, right? Olecranon process and the coronoid process that fit over that trochlea and capitulum, right? And it allows simply one plane of movement, up and down, flexion, extension, bending, extension, straightening. Does that make sense? And again, you can see very easily, concave of the ulna, convex on the humerus. Last but not least, we have our pivot joints. And this is where a bone is spinning on its long axis. Oh, you guys are just right on it today. Well done. Thank you. So, we have one of your classic examples of this is the radio-ulnar joint between the radius and the ulna. So, remember, ulna is medial, radius is lateral, right? When I have my palm upward in anatomic position, radius is lateral, ulna is medial. I rotate, I do pronation, where my palm goes down. And literally, the head of the radius just spins in place and allows that bone to roll over, or allows the radius to roll over the ulna. So, palm down, palm up. Palm down, palm up. And that motion is a pivot joint, which makes sense, right? It's literally just pivoting on that spot. The other place that happens is in the atlantoaxial joint. So again, atlanto means atlas, right? Axial means the axis. So this is C1 and C2. And again, that's what allows this little bit of rotation. So actually, that was too much. It's about there. That's the amount of rotation that's allowed. Again, between that little sticky-uppy thing on the axis, what's that little sticky-uppy thing called? The dens that rotates and lets the axis C1 rotate, the atlas C1 rotate on the axis C2. Here's your hinge joint pictures. Okay, your elbow joint, your knee joint, these are classics. Also the joints between your fingers and toes, right? All they simply do is extend and flex, right? I can't take my finger and somehow turn it sideways. Well, you can, but it's not very good for the joint. Okay, that'll be a nice dislocation. And then last but not least, we have the pivot joints, right? So here's a nice picture. They did a really nice job with these x-rays here. So here's the atlas, the axis, C2, and you can see the den sticking up, right? And it's surrounded then by the atlas, C1. And so it will literally just spin on that little dens. That's like its axis of rotation right there. Any questions there? And again, I did break down those pieces there in your study guide, giving you some examples and understanding what they do. Multi-axial, biaxial, monoaxial. Any questions there?